Hi there! Here is another episode centered on the Arduino. Continuing the discussion on the usage of the serial monitor, today we will see a few examples on how the serial monitor can be used to provide debugging information when something is wrong with a sketch we designed and we need to figure out where the error is located and how to fix it. Another use of the serial monitor as a debugging tool is to provide information on something we are learning. For example, a new library or a sensor that we never used before. Let's begin. The way we use the serial monitor for debugging is to insert print instructions within the code to be debugged. During the execution, we check on the serial monitor if the print comes out. If it does, we know that the code where the print instruction was added was executed, otherwise it wasn't. In addition, we can add to the print some crucial information that the program is supposed to handle at that point during the execution. That way, we can better understand what is going on and why the program is not behaving as we expect. Let's take a look at how this is done with a couple of examples. In the first example, we will use the example program named Blink that can be found in the Arduino IDE under File, Examples, Basics, Blink. Let's bring this program up. This program is very simple. All it does is to use the built-in LED on the Arduino board and makes it blink at 1 second interval. We can see that in the setup function, pin mode is called to tell the Arduino Uno that the built-in LED is going to be used as an output. Then in the loop function, we see a call to digital write that forces the pin, where the internal LED is attached, to go high, thus lighting up the diode. Then there is a call to delay that causes the program to wait 1 second or 1000 milliseconds. Then another call to digital write sets the pin back to low, and so the LED turns off again. After that, there is another delay of 1 second, and then the cycle repeats over and over and over again. When this program is compiled and uploaded to an Arduino Uno, the built-in LED will immediately start blinking at 1 second interval. But let's assume now that the LED does not blink. What is going on then? Something wrong the way we wrote the program? Or something wrong with the LED? Maybe the LED is broken? One way to find out is to add a couple of prints in the program to see if those lines are executed. If so, we will know that the program goes through those instructions and the problem is elsewhere. Let's see how to do that. So first, let's add to the setup function of our program the instruction to initialize the serial monitor, otherwise we won't be able to use it. And the instruction is serial.begin 9600, which is the speed of the channel used by the computer to communicate with the Arduino. Here, that way. Now, we can add a couple of printouts to the loop function. For example, we can put something right before the instruction to turn on the LED, something like serial.print about to turn the LED on \n. This \n is used to force the output for the next print to be on a new line. Otherwise they will be attached to one another on the same line. Then we can put something similar right before turning the LED off. Serial.print about to turn the LED off \n. This way, when the Arduino Uno runs the program, we will be able to see on the serial monitor if the lines in the loop function are actually executed or not. Let's do it now. First, we need to verify and compile the code. Now, we upload it to the Arduino Uno, and the program should start running right away. So, let's open the serial monitor and let's check if we see those printouts. And here they are! And as you can see, every second a new printout comes out, telling us that the LED is turned on and off alternatively. This confirms that the software is running correctly. Now, yes, I know this is a very simple program and it wasn't necessary to do something like that. That's true. But this was just an example, so now you know how to add printouts to a program to confirm that instructions are executed in the right order. In fact, in a much more complicated program, the program's flow can traverse different branches depending on certain conditions. These prints can help us figuring out whether or not those conditions happen, so if the program follows the correct flow or not. Let's see an example of that. For it, we use another program. We already just saw that. It's the same one we used in the previous Arduino episode to learn about the serial monitor. Since this program already uses the serial monitor, the instruction serial.begin is already here in the setup function, and so we don't need to add it again for our debugging purposes. Also, in the loop function, there are already some print instructions that were added to show how the program worked, and in fact, those were actually debugging printouts, like this one on line 31, or this one on line 37. We also had a printout to verify the content of variable byte received before testing it on lines 28 and 24. And that printout is the one on line 26. In fact, to make the program work, we really don't need any of those lines from 22 to 26 or those on 31 and 37. Even if I didn't tell you at that time, we were already using the serial monitor to do some kind of debugging, although in that case it was more like something that we used to learn how the program worked. To prove that, let's run the program again, like we did in that video, and then let's run it one more time after stripping out all those print lines to demonstrate that we don't really need them. So first, let's verify and build the program as it is. Now let's upload it to the Arduino. And now let's open the serial monitor so we can see what's going on. Here. Let's enter some digits so the program has something to run with. And now you can see all those messages coming out during the execution of the program. Now let's go back to the code and remove all those print lines. Let's verify and build again the program, since we changed it, and now let's upload it to the Arduino one more time. Now, if we input some digits in the serial monitor, we don't see anymore any response back, but we can still see the LEDs on the board react to our input. This is how usually a program is executed on Arduino. We don't put many printouts in there. First, because we do not need them once we run the program in normal conditions, because we are not going to look all the time at the serial monitor. And second, because those printouts take valuable space in the Arduino memory, thus limiting the size of the programs that we can write on it. So in the end, we only put those printouts that we really need, and once we are sure the program works fine, we can even remove them if we don't need them anymore. We have seen how to use the serial monitor to print information from a running program on the Arduino board, in terms of what the program is executing and what is the available data in certain points in the program. These basic techniques are just examples on how the serial monitor can be used to provide a lot of information whenever we need. Again, take for example the case where we need to use a new sensor and we need to learn what kind of data provides and how to use it. In cases like this, the serial monitor is of valid help to make available all the information generated by the sensor and understands them before we make a new program to use it. In the next video on Arduino, we will talk about how to write simple programs for it. We will in fact explore the basic syntax of C++, which is the programming language used by the Arduino IDE. In the meantime, don't forget to subscribe to the channel and give a thumb up to this video. Another great way to support the channel is to donate some money through patreon.com or through PayPal. Details are at the very end of the video and in the description below. See you in the next video and happy experiments!